Okay, so let's continue on page 6 of that extra information. So this is Web Resources for R, Part 2. So here's just some other places to get information, but in a different way. The first one I briefly mentioned it. And there's something called the R Journal, which is the official publication of the R community. And before that, before it came out in 2009, there was something called the R Newsletter. And there's a lot of good information on there. They'll have like short little articles on packages or other things about how to use R. And in particular, one I want to point out to you is the very first issue. There's something, in the very first paper in it, there's something called What is R? And while obviously it's 10 years old, it's still a useful resource. Another journal that's helpful is something called the Journal of Statistical Software. This came about in the mid-90s, and both these are free, by the way. This journal features papers on any software package. But because of R's dominance, at least with respect to developing new statistical methods, it's primarily now just R. There's a number of blogs out there, in particular r-bloggers.com. Basically is kind of a central place where stuff from other blogs are kind of filtered into. So this is statistics and data analysis in Python with pandas and stats models. So we were talking about Python earlier. Well, there's a little bit about Python and how R is connected with it. But there's a whole bunch of stuff. Like here's a posting about how Lloyd's of London uses R, using Google spreadsheets with R, and so on. But my favorite blog is the one published by Revolution Analytics, which I think all of you, or some of you at least, are familiar with this company. And this is done by David Smith. And I subscribe to the RSS feed for it, and eventually it will come up. And you get about 1 to 2 postings maybe per day there. And I've learned a lot about R myself from this. He doesn't talk much about Revolution, the software package for Revolution's analytics, but he talks about just R in general. And I have found this to be a very, very useful resource. Twitter as well. There's something called the R language tip of the day. So you get one little thing in your Twitter feed per day if you subscribe to it. If you wanted to tweet something in Twitter about R, use the #RStat hashtag. There's an R wiki. There's also a Google search that filters out non-R websites. A problem that's used to be more so a problem in the past was, if you did a Google search and you typed the letter R space something, you might get something else than what you want. So there was a way to filter out results that were ones you didn't want. Now, though, when I do Google searches with R, I often get to where I want to be. So maybe it's not as important as it used to be. Nice little web page about R by example. So let's say you want to know how to do regression. Well, there's going to be an example there of how to do it. And also my own teaching websites available through my web portal. I use R in all my classes now, and all my course websites are open to the public. And you can download lecture notes. You can actually watch videos of me teaching it. And all my R programs, everything's out there. So, for example, categorical data analysis, you can go to the website and see how I taught it last time when I taught the course. Okay, any questions? Okay, we left off on page 23 of the main handout. So now we're going to talk about TIN. TIN stands for This Is Not Notepad. Yeah. If you could open up TIN on your computer, please. And just to verify with all of you, once you do that, go under Help and do About. I want to know how many of you are actually running 1.17.2.4. So if you're running that, okay.
Yes.
Okay. And you're not.
I'm the only goof.
You're finding it? Okay. So we'll come to the new version of 10 in a little bit, but we'll focus first on using this version. So what I would like you to do is in the files that you downloaded, there should be a file called initial_examples.r. Why don't you open that in R? And one way to do that is just to simply find the file and then just drag it and drop it into your editor. That's all you need to do. So drag and drop into the editor, and it will open up the program.
You can also double click it.
Yeah. Thank you for bringing that up. Yeah. Initial examples. Oh yeah, that's unfortunately hidden up there. Initial_examples.r. And basically everything that we've done in R so far, unless I did it on the fly, is contained in this program. So at the very beginning, you see some stuff that's, well, first of all, you see that stuff's color-coded. This is one advantage of this editor versus the one that's in R itself. The code is color-coded to its purpose. So for example, comments. So descriptions that you may have about what this program does or what this code does, you start a line with a pound sign. That's how you do a comment in R. And so you can see comments are color-coded in red. I'm sorry, in green. Functions. Notice they're in blue. If you had stuff in quotes, it would be in burgundy. You can change the color scheme if you really wanted to. There's a variety of ways to do it under options. Well, let's look at how we can then run code that's in 10, run it in R. So why don't you just simply highlight some of these, some initial code, and go up here to the Send Selection icon, which is the fourth from the left on what's called the R toolbar. Does everyone see that? Okay, once you come up there, just click on that button, and it dumps the code into R. Let me do it again.
Pretty tiny. It almost looks like it's a right justified.
Yeah, but it dumps it in and runs it.
What
Yeah.
are you all working on? What sorry, I don't see the toolbar.
Initialexamples.r.
Which is where?
So there's
There you go.
download program file, like
Yeah.
zip file. But that's where download the zip file.
Is the toolbar not there?
It's a toolbar.
It's there, but it's not, it's like faded.
Okay. Do you have my program open in it?
Yeah, she doesn't. She's got the piece highlighted.
I have that. Yeah. Why would we have a document? So you said.
You don't have R open.
Oh, I have to have R.
Yeah.
Download a zip file.
Yeah. Since we're using R, you have to have it actually open. It will not open it for
I
you.
don't know if I did that. I just did the R. And then just minimize it?
No.
It doesn't matter.
Instructions
Doesn't matter.
on his screen when we came
Oh.
in, it said go to this website.
So the fourth from the left?
File.
This one?
Go to
Yep, just click on that.
/workshop.
And it dumps it into R.
Ah. So
on
now if I
the
go in
internet?
the R, I'll see that.
Yep.
Okay.
Are we okay? Now, one of the things that you probably notice is that, yes,
2 minutes here.
I'm sorry.
You go to chrisporter.com/workshop.
Okay.
See all the files in that zip file, download that zip file.
This one?
Yes. Save it.
itself, and you can send code from there to there using
All?
is that right, Earl?
Yeah.
Okay.
There's all your files. Now double click on the initial example.r. Double click on it, it will open it again. Right, so just like SPSS, you can highlight the syntax and just run that load portion.
Reset?
Yeah.
Okay.
Thanks.
Yeah. So when the code transferred to R, you might have noticed something annoying happen. That immediately when it ran in R, basically you came back to the 10 window. Does that sound familiar? Okay. Now obviously if you're running something in R, you want to see what the results are. You don't want to see your program editor anymore. So what you can do is you go under Options. There's something called Return Focus after sending R. Just simply click on it. And once you do that, you'll come back to this window and try running some code again. And you get what happens on mine, which is I'm focused on R. I'm not for sure why that's the default.
You have to do that each time, or does it?
No, I will remember it the next time you open up 10. Yeah. Let's see. So 10. Also, I guess if you wanted to run you don't need to do this, but if you wanted to run the whole program, there's a Send All button. And you can explore some of the other stuff on the R toolbar if you want. I just mainly use this Send Selection button.
Is the color coding in this example intentionally done by you to highlight things, or is it done automatically?
Done automatically.
Okay.
Yep. So speaking of color coding, let's say for some reason you wanted to preserve this color coding if you wanted to, let's say, maybe copy and paste some code into Word, for example. So what you can do is highlight it, come up here to Edit, Copy Format to Export, RTF. And let me just open up a plain Word document here real fast. And now the color coding is preserved. This is often helpful for me when I teach because it helps me read my students' code, for example. Okay. Also, why don't you go to an empty spot in the program, it doesn't matter, and start typing pnorm, and then a parentheses, and stop there. Look what happens to your screen, or hopefully it happens to your screen. Like if you use Excel a lot, if you type a function in a cell, you'll have Excel tell you, okay, what's the syntax for that function? Well, I don't know why this is doing this on my computer here.
Is there a reason why you wouldn't be able to type on it?
Is it working now?
What's the read only?
Under options, read only.
Okay.
So anyway, so it shows you the actual syntax that we saw before.
Oh, in that thing.
Yeah. Yeah, so that can be very helpful, especially if you're just starting to learn how to use tin.
And that doesn't pop up
Or
if you're
R.
actually in R and typing it in.
That is correct. Yeah, but obviously that would be a nice little feature.
So can you somehow make it copied there? Or can you just read that?
No, you cannot make a copy, so you'll have to go ahead and type it.
Okay.
Um,
It doesn't auto-populate.
No. But one of the nice things about R is that it's an open community. So if you wanted to create your own editor that had that option, maybe everyone would be going to your website and start downloading your editor because that would be a good feature. Now, the way that I use R and tin then in my office or wherever I'm at is, well, I guess in my office or at home. What I do is I have a multiple monitor environment. So I'll have, let's say, maybe R in this monitor, I'll have 10 in this monitor, and that way I don't need to ever flip-flop back and forth. So, especially multiple monitors are a lot more prevalent now than they used to be. That's a very nice thing. If, though, you only had one monitor, I have Windows 7 on my computer here. I can just simply dock it here, and I can take this window and dock it over there. Oops, dock it there, and now I got them side by side. And I could use it that way without having to flip back and forth between the different software programs. Okay, so that takes us to page 25. So in order to understand then why I had you use the older version of 10 versus the newer one, you need to understand that R can basically run in two different environments. One's called MDI. One's called SDI. The M stands for basically multiple windows. So inside of R here, if you notice, I have inside of R itself, I have a console window, and based upon something I did before, I also have a graph window. It all lives inside of one window. Then there's also the SDI environment, which stands for single window. So this is what SDI looks like. And all this is, let me make this go down here, is just simply the console window. So if I did something in R that would create another window like a graph, it would be totally outside of my main window there. Okay. The default way that R runs is MDI. And so, and that's what we're using here. And you can always find this out if you go under Edit, GUI Preferences. You can see at the very top, notice MDI is listed.
Why would somebody want a single one?
Well, I think it more stems from people, let's say, using in a Unix environment where that's a lot more common. Where you would have one window for this, and it can be all over your screen versus everything contained in one thing like we might be used to like in, for example, a SAS environment. So I think that's why. But you will see that a lot of these external program editors, so for example, 10 is not made by anybody who's connected with R. Other program editors are not made by anybody who's connected with R. And you'll see a lot of these editors are going towards this SDI mode. So the version of 10 that I had you install, the older version, is the last version that allows you to do the MDI mode. And that's helpful to have in a workshop like this, have you use an MDI mode, because then I don't have to explain MDI and SDI at the very beginning of the workshop, and I don't have to have you immediately, when you open up R, change something. So that's why I had you download the older version of 10. And I use the older version of 10. I don't use the newer version. But if you wanted to use the newer version of 10, you'll need to start R in an SDI form. And so one way to do that is, let's say you have R on your desktop someplace. Click on Properties, and you can put a little bit of extension. I know that's small, but it is located on page 26 of the notes. Basically, in the target field, do space -- SDI, and that will allow you then to immediately then have an icon that will automatically open in SDI mode. And you can use that then with the new version of 10. Now, I do not have the new version of 10 on this computer because the new version doesn't like to operate with the old version. So I can't interactively show you the new version, but what I do have is a screen capture, what the new version looks like, and you can see that it looks very much like the old one. The only difference is that there's new looking icons for how you send the set of code that you've highlighted, how you send it to R. So it's a little right arrow. Remember that return focus thing that we did with the original version of 10? Well, now there's a little thing on the toolbar to allow you to do that. And then lastly, if you wanted to start R, if you're already in 10, well, there's actually a little button that allows you to start SDI mode immediately. So it's up to you, which one you want to use. Myself and my students typically like the older version, but obviously the newer version is there too. Okay, that takes us to page 29. Now there are many, many other editors out there. Here's one. Let me make this a little bit bigger. What's that?
She's distracted by the beat.
Oh, okay. Now that's on the Outer Banks in North Carolina. I went there a few years ago. Very nice. It was to make you relax, but not necessarily sleep or anything like that. Anyway, does anyone by chance use the editor called WinEdit? By chance? Okay. Well, there is a package in R called R WinEdit that basically adds some stuff to your WinEdit so that you could use it. And I used to use this a lot. I don't use it anymore. Won't get into the reasons, but what I do like with WinEdit is some of the color coding is a little bit better than what it is in Tin. So if you're interested, you can take a look at it on your own. WinEdit, though, is shareware. So after 30 days, you'll have a little message pop up saying, we want your money. Please pay us. Where Tin is completely free. And lastly, for the editors that we're going to look at is this one called RStudio. This is still in a beta test form, but I've had a number of people really like it, especially these were SAS users who were used to this kind of, this is more like a kind of a SAS environment, where with RStudio, you have a little window that has your program in it, and you can transfer code, just very similar to what we did with Tin, down to your console window. Now, if you notice over here on the right-hand side, you saw some stuff change. Well, it gives me my history, but it also shows me some stuff about a workspace. Let me actually get to something here. Notice that original example where we had save gets 2 plus 2. Now you see basically what the ls function or the objects function would give you inside of R. And in fact, if we had a data set here, you can click on the data set and it will open so you can see it. On the bottom right-hand corner, you have some information about your file structure in your computer. If you had some plots generated, we'll go here. Here's a bunch of packages that you have on your computer, and you have direct access to help. Just to give you an example, I'm in the process of writing a categorical data analysis book, and my co-author never used R before, but my book is totally focused on R. So I've had to teach him a little bit about R. And I told him about these editors, and he actually picked this one. He thought it worked out better for him. So maybe new R users might prefer this because everything's in one central location. Okay. So, yeah, this one's free. Thank you for bringing that up.
Do you have that in your notes?
Yeah, that's on page 32.
Okay, yeah, there it is.
Okay, so page 34 then. So as I said, there's many other editors out there. If any of you have used Emacs maybe before, this is more popular amongst Unix users. There's an add-on to Emacs called Emacs Speak Statistics, and it allows you to work even with SAS, for example, with the color coding, work in a very similar manner to what Tin does, and you can use this with R if you wanted to. That website there also lists all the other editors that are available. Okay, so that's the very basics of R. Now we're going to talk about a regression example. And so what I would like you to do is in Tin to open, there's a program, oops, let me get to it. There's a program called gpa.r. Why don't you just double click on it, open into Tin. And it's going to look like this. Is everyone there?
And so if we didn't close the other one, what sort of happened to it?
Well, it should be, you should see a tab.
Oh, I see, yeah, okay.
And also make sure that you have, there's corresponding data files that we're going to read in shortly, like for example gpa.txt. Make sure that those data files, also gpa.xls, are available in a folder that you can access. I'm not for sure. I mean, you might have to actually physically unzip
Yeah.
the files. Yeah, then you're fine. I don't know if it would work if you left it in a zipped version or not. Okay, we were ready to go on? Okay. So here's the background for this example. Let's say that maybe an Office of Admissions, maybe at University of Nebraska, wants to get a general idea of
Detected that this program has reached the duration limit for 3 or fewer participants and will now attempt to close the conference. If you wish to remain in conference, please press any key now.
You should just have a key. You should have a keypad right on the monitor.
on this monitor.
Yep.
I don't see necessarily what to press.
The system has detected that this conference has reached the duration limit for 3 or fewer participants and will now attempt to close the conference. If you wish to remain in conference, please press any key now.
That might have done it. We'll see. She's not saying she's attempting to hang it up again.
Okay, maybe because she's already hung up.
Robot daycare, actually.
Yeah, we can hear you.
If you Google it,
It's still recording.
Okay.
Go ahead.
Okay, so let's see. So maybe University of Nebraska Office of Admissions. They want to know, well, what kinds of students should we admit to the university? So what they might do is, let's say, take a sample of some students that they've admitted in the past, or they've let in the past. I think in the past they've actually had open admissions. And they watch how they do during their college career. So they get their end college GPA, and also they have information about what their high school GPA is. And based upon that, they want to maybe look at a regression model. Given high school GPA, what would we estimate their college GPA to be? And the Office of Admissions maybe could use that for future admission decisions. Okay, this is not a real data set, though. I have to admit that I did make this up just for, it was a very simple example. And the data set actually looks like this. This is just a plain old ASCII text file where we have high school GPA and then college GPA as well. Notice how I use dots in there for variable names. And so the first student, let's say, had a high school GPA of 3.04, and in college they had a GPA of 3.1. Okay. Now what I like to be able to do is get that data into R so that I can use it. And for this kind of a file, for a plain old ASCII text file, I can use the function called read.table, where the first argument says, well, what's the file? Where's the file located and its corresponding name? Now notice in my address here, this is the actual physical location of my hard drive where it's located. And notice how I have double slashes there. You need double slashes. Can't just use a single slash. Cannot do that. You could go the other direction, though, if you wanted to. Yeah. Sorry, I didn't say that very well. So this is what Windows would give you, that slash. So you have to actually physically change whatever Windows given you. So I can come up here to my Explorer window. I can copy, paste that in, and go ahead and just add a slash.
I think that's right for a app or program, not a Mac.
Which
Yeah, I don't remember why that was needed. It could have been due to Unix, where Unix, I think, had slashes in the other direction. Okay. So anyway, so why don't you type in what the actual physical location is on your hard drive for this gpa.txt file.
Instead of typing, can we
Or copy paste.
go there?
Well, you're gonna need the address. You need somehow to get the address. So you can come up here to get the address to your Windows Explorer window and copy and paste it. You can't necessarily, let's say, just drag gpa.txt into the tin. You couldn't do that.
Or click?
Well, you could right-click on it, Properties, and you could find the location that way if you wanted to.
But you have to copy paste the location.
Yeah. You need to get the location somehow. It doesn't matter how you do it. You just need it to be there.
Do we need to do the text one?
Yeah, the txt file.
So if I go and click click this, but this doesn't have the file right. I've seen people do without like Jim.
Photoshop has .zip. Did you keep the .zip?
I'm not for sure if it will work if you keep it in. Yeah, you're going to need to extract the files.
I think I did that.
Yeah, you did.
So you just have to go with it. It's in a separate
Right, that
direction.
folder right there.
That's the folder. Got it, got it.
Okay, so it does get only one message. There's no.
So delete doesn't work on this? Only the backspace works?
The delete should work.
Okay, I got it.
Okay. So also there's two other arguments there. Header equal true, that corresponds to the variable name there in the first row. And then SEP stands for separator. How's this delimited, basically? And space delimited, so you actually just do quote, quote. You don't even need to put a quote, space quote in there. So once you have that, and if you typed in everything right for the folder structure, what we can do is just simply run that, and notice what's going to happen. It's going to put the results from read.table into the object GPA, our data set.
Okay.
Did it work for everyone?
Yeah. What is it supposed to just?
It just, or you'll get what I got there.
Yeah,
You
got it.
created an object.
Yeah, thank you. Yeah, you created an object. Now, this object, you can take a quick look at it. Actually, you can just simply type its name and hit enter, and there's the data.
Save. Got it.
Okay. Now, often you'll have larger data sets than this, so it's nice to work with something like
So after you read it in, you just had GPA and probably.
Suppose you just want to do a quick check to make sure it looks right. Well, you can use the head function. If you say head GPA, you get the first 6 observations, or first 6 rows of the data. There's also a tail function that gives you the last 6. So it's a quick way to check.
So is head only always the first 6?
Yeah, and you can change that. There's an argument called named n. So if I did n equal 2, you get the first 2. So the default is 6. just to verify that you read in the data okay.
Imagine if you had 100,000 records.
Okay, so instead of saying just GPA, if you have 100,000 cases, do 2 or 6, and it'll show you the beginning or the end.
Yeah, just a quick check.
Sorry, it takes me a bit.
So we're on page 37 in the notes to help you out here. Now this object that we have here, GPA, it's a data set. In R's terminology, this is called a data dot frame. So data period frame, data dot frame. So you can think of it as kind of a frame of data. So it's a special type of object in R, a data dot frame. Now, you don't need to do this. Let me just show you real quick. If I, let's say, had a comma delimited file instead, well, then for the SEP option, or argument I should say, put a comma there. Or alternatively, something a little bit quicker, you could use the read.csv function, and notice there's just the argument header equal true. So either or will work. A lot of people work with a comma delimited file versus maybe an Excel file because you can easily save an Excel file as a comma delimited file in Excel. If you wanted to write out a comma delimited file, let's say you maybe did some calculations and you want to save a data set, well, you can use the write.csv function or the write.table function. Now let's talk about how we can read in an Excel file, since this is often a common format, at least for easy data. So this is where we need to use this RODBC package. So hopefully this will work for all of us. The first thing that we need to do is make sure that the functions in the package are ready to go. So all of you have probably done this before. Library package equal RODBC. Now I can use functions inside of there. And this is a powerful package to work with databases. And we're just simply working with an Excel file here. And the first thing I need to do is actually make a connection to that database. So I say ODBC connect Excel, that particular function. I specify where my Excel file is. So you should change the address there basically to wherever you stored your Excel file. And then I put this connection then into an object called Z, for the lack of a better name. Then I need to tell R, why don't you go fetch the data, basically, from this Excel file. So I say SQL, fetch. The channels, well, where is it located, basically? And then the SQ table corresponds to what's the name of the sheet, the actual spreadsheet inside of the Excel file. And if I just show you real quick what the Excel file looks like. There we go. So you can see that sheet's called Sheet 1. And then I put the results into an object called GPA.xl. This will contain my data.frame. I close the connection, and then I run the head function just to make sure it worked okay. Why don't you run that code, and let's hopefully have it work. Now, I will tell you, one reason why I was a little hesitant to run that is because I've been having some of my students tell me that they've been having some problems with 64-bit versus 32-bit stuff. And unfortunately, this has just happened for the first time this semester. And actually, I've been away from teaching for about 15 months because I've been on sabbatical. And now that 64-bit computers are more prevalent, also obviously there's 64-bit R as well, I think there's some kind of trying to intermingle 32-bit stuff with 64-bit stuff that's not working quite right. I don't think it's necessarily a problem with R. It's just maybe a problem, a little bit, at least with my reading, it's a little bit of a problem with, I think, if you have, let's say, Office 64-bit or Office 32-bit on your computer. So just to let you give you a little bit of warning about that.
That was the problem we initially had with SPS stuff, was that when we installed trial versions before we deployed and reimaged, we installed 64-bit version of Office. Well, there isn't a 64-bit Excel driver, so we had a problem. So everybody's new reimage actually has a 32-bit version of Office that don't have the 64-bit version of Excel. And there's still no 64-bit driver for Excel as far as I know. So
Isn't SPS usually a bit behind?
it's
always easy to blame Microsoft, isn't it?
Everybody's
Yeah, but I mean, it's usually their fault.
SPSS, but
Yeah.
I'm like, this one is not
Okay.
an SPSS problem.
Now, there is another function in this package you can look at on your own that allows you to do Excel 2007 and 2010 files, the .xlsx extension. But I do know there are some 64, 32-bit problems with that.
Is there a way to open SPSS file also?
I believe there is, and in fact, I wish I would have looked that up. I didn't. I don't use SPSS, but I believe that there is a function that allows you to do that. So SPSS data file. So now we got our data in R, and we're going to just simply use the object GPA. And why don't you just type summary GPA, and we get a nice little summary of what's inside of GPA. We have two variables. We have information about the median, the mean, and so on. So just a very simple data summary. Now, often you will want to access maybe just part of the data set. Maybe, for example, you just want the high school variable, high school GPA variable. And the way to do that is as follows. Type GPA, then a $sign that basically tells R you want to go inside the data frame, and then the variable name. And again, this is case sensitive, so capital H, capital S, dot GPA. If you just run that little segment of code that I have there, there's all my high school GPAs. That's how I access a variable.
So say you don't remember what's in the data file, can you just do that summary, or is there like a list of my variables?
Well, I mean, you could do this, the head function, or you could use the names function. This is in the notes.
You can get like 147
Very cool. Yeah.
You open it in Excel and keep that in your second monitor.
Yeah.
So names GPA. Now, a quick note that's not in my notes is that you could actually have variable names that have spaces in them, but if you do that, you will need to, when you say GPA $sign, you need to put a quote around that variable name, the whole variable name, if there was a space somewhere in the variable name. Okay? Now, there are other ways that you can access just part of the data.frame. You can basically work in like a matrix notation kind of form. So if I type GPA bracket, and you can duplicate this too, bracket 1, 1, end bracket, what do you think is going to happen? Row 1, column 1. So the first high school GPA. What do you think is going to happen if I do GPA 1, comma, and I have nothing after other than the bracket? All what? All columns. So basically the first row. I could do comma 1 instead. Well, maybe I want a number of observations corresponding to maybe I want just the first 5 observations, and I could use the head function for this, but I'm going to do this instead. I could say GPA bracket 1, 5. The colon's interpreted as basically the word 2. 1 to 5, and it means integers. So 1, 2, 3, 4, 5. There's the first 5. Another way is I could have used the C function, just like what we did before, and get exactly the same thing. Let's say also I'm working with the GPA variable, and this is not in the notes. So there's the high school GPA variable, that is. Let's say that I want maybe just the first observation where I'm starting with GPA $sign high school.gpa. Well, this is no longer a data.frame. Instead, it's a vector, similar to what we saw before with when we said x gets c 1, 2, 3, 4, 5. So to access actually just the first observation, I only need one subscript, or one index, I should say. Okay. Any questions? So it's like working with matrices and vectors, if you're familiar with that. Here's a question for you. suppose I did GPA bracket, comma, -2 end bracket. What do you think might happen? R is going to close out and bomb? What's that?
Last
No.
two?
No. Negative basically means don't do it. Don't show me column 2. Just show me column 1. So if I did, let's say, 1:10, and I'm going to put a negative in front of everything, notice I'm going to get the last 10 observations. So that can be a useful thing to know if you just want part of a data set. Okay, so page 40 then. Well, often you would like to access part of a data.frame in like a conditional manner. Maybe, for example, we only want to see those students who had a high school GPA of less than 2.5. Okay? So we can do logical comparisons in R. For example, I could say GPA $HS.GPA, and if I say less than 2.5, if I run that, what R does, again, operates basically on vectors of information. It will do the logical check on every single observation. Okay? So we get trues and falses. And then we can combine those trues and falses to this way of using basically a matrix to access part of the data set. So notice how I put this in there for basically the row index. And then if I highlight that whole code there, I get those individuals who have a GPA of less than 2.5, high school GPA that is. Because what R does, it interprets the trues and falses in a manner of true, I want the row, false, I don't want the row. Also, what R will do is that you can do math, basically, on trues and falses. R converts trues to ones, falses to zero. So if I say sum all the trues and falses, I find out that there were 11 rows that corresponded to that. Any questions?
How do you select, like, I only want to work with whatever the condition is, all the cases above 2.5, in terms of having my computation?
Well, I mean, you could just change this to greater than, and maybe, let's say, create a new data.frame. Suppose we call it GPA 2. And now GPA 2 only contains those particular cases.
Now, does that selection maintain itself for all your subsequent commands, or does it only occur in that one command line that you write?
There's an object called GPA 2 that has that selection that you can work with. Now, perhaps, too, what you might be interested in is, let's say I'm using a function. Like later on, we're going to be using the function LM to fit a regression model. There are arguments in there that say, I want to select only the cases that correspond to some condition. Maybe that was what you were getting at. So there are those kinds of capabilities.
So every time you need to subset your data, you've got to create a new GPA 2.
That's one way to do it. Another way is if, typically you want to subset your data to do some kind of computation on it. And there are often arguments in the functions that do the computations that allow you to do it.
Let's say you wanted to segment your data and set some aside, do a whole bunch of different computations on one subset of data. Is there like a global filtering you can do, or does that need to be called each time to do some kind of function?
Could you repeat that, please?
Let's say you wanted to test a holdout sample and a modeling sample.
Sure.
And you wanted to filter your data somehow to only give you a subset of records of data, but you wanted to do a whole bunch of different things to the data.
Mm-hmm.
Is there a global kind of filtering to say, okay, now just use these records until I say start including all the records, and everything I do from here on will just be on that subset? Or do you need to call that filtering in each time you do some sort of function?
I think I kind of understand what you mean. Are you maybe referring to, if you think of working with databases, you could be working with one central database, and you could say, whenever I access it, I only want some kind of condition and pull out those records. There are packages, especially if you're working with big data, there are packages that work like this. Basically, what's happening when I'm doing this, I'm actually putting something in my memory. And if you're working with a big data set, you don't want that. So there are packages that allow you to do it. I do not have experience with them, but I do know that they exist. Because one of the early concerns of actually S+, and then eventually this migrated to R, was you can't work with big data sets. If I have 1 million some records, well, you're going to have a problem because you would have 1 million records in your memory, and maybe it's not as bad of a problem now if I have 8 gigabytes on this memory on this computer, but still, you can imagine a data set where you're going to run out of memory problems. And so packages started being developed, I would say, around 2005, 2006, when I first started seeing them, that allow you to do that. In fact, if you wanted to, let's say, maybe fit a logistic regression model to a big data set, there's a package, I think it's called Big GLM, something like that, that incorporates things that is not going to clog up your memory. Okay.
We occasionally work with big data sets.
Oh yeah.
Very deep and very wide.
Yeah. And a lot of stuff I've learned about big data sets, because to be honest, I don't have a whole lot of experience with working with very huge data sets. A lot of experience I've gotten is from this Revolution blog. And if you're familiar with the Revolution software, which is basically R, but you have to pay for it and some other extensions, they are really focusing on the big data people. And they've come up with additional things that might not be available in R that might help out. Okay, one last thing. Often you see, you want to do like an if-then-else kind of condition. Well, there happens to be an if-else function in R that will help you do that. So simply, if you want, you can execute this too. If-else, test the condition. And what I've done here, just to show you, how you can get multiple conditions, I said, let's look at high school GPAs that are less than 2.5, and that's what the ampersand does in R. College GPAs less than 2.5. If I find a yes, assign a value of 1. No, 0. And I put that in an object called test.condition, and then I sum it up, and I find out there was 10 observations like that.
So if you use yes and no instead of true and false, even though it returns
Yeah.
values of true and false.
Yeah. If software packages were consistent with all their terminology.
So do you have to have yes here instead of true?
Yeah.
If you put true, then what? It bombs?
We can try it. I've never tried it before, but I would assume it would, because if you look at the help file, there's not. We can actually.
No, it gave an error in
Yeah.
if else.
Yeah. So there's the syntax, for example. Yes and no. You need to use those. But what you could do is just not use the yes argument name and just simply put the number 1 there instead. You could do that.
Real quick, since everybody thought that it just ran,
Yeah.
right, if you go back to your
Yeah.
R screen,
So this is what's on my R screen was basically, since it did not run, and then when I wanted to use the object test.condition or cond later on, it goes back to what it was before. Yeah, the object was not replaced, so it's what it was exactly before. So you can see you could get into trouble that way if you're not paying attention.
Yeah.
If you wanted to do, let's say, maybe an OR condition instead, you can use a vertical line. And that will allow you to do OR.
What was the vertical line?
OR.
Or.
So in this particular case, there happens to be 11 individuals in my data set that have a GPA, high school or college, that's less than 2.5. Okay, page.
strictly the less than sign, and is it less than equal to?
You could do that too.
Or
It's less than, it would be less than or equal.
okay.
If you wanted to do maybe equal, you have to use 2 equal signs. This is not in the notes. You have to use 2 equal signs. The reason being, because notice how we're using equal sign already. Yeah.
How are you using what?
What's the 2 equals sign?
I'm
Sorry. Equals.
Yeah. So notice in my to give an argument name with its value, I have to use an a single equal sign. So that symbol is already used. So if I wanted to do a logical comparison of is something equal to something else, I use an equal equal.
And could that equal sign also be the two arrow things or no?
What do you mean the two arrows?
Like you have just about 10 characters to the left of that.
Oh, well, I mean that's less than dash. So
yeah, could I replace the equals you have there with less than dash?
No, because I mean that's making an assignment. So it's putting something into an object versus a logical comparison. If you wanted to do not, this is not in the notes. Pound
Not
yeah.
Is that exclamation?
Yeah, exclamation mark equal.
Can I also use greater than, less than?
I do not think so. I've never tried it, but let's try it. So if I do 2 less than greater than 2, error. If I do this, false.
Okay.
So those little things, especially when you're first starting to use a new software package, is like, how do I do this very very simple thing? And it's just a matter of getting experience and knowing the little segments of code. Okay, let's move on to page 42 then. So, one of the first things that you want to do if you are going to look at a regression model is do a scatter plot of your data. So this is our first experience with using our graphics. The function we're going to use is called plot. It's in the package called graphics. You can execute this code as we go along here. So to do a very, very simple scatter plot, tell R what's on the x-axis. So x equal, notice how I access high school GPA, GPA $HS.GPA. Y-axis, GPA $college.GPA. I'm going to use college GPA as my response. So if you transfer that code to R, up will pop up a little graphics window.
Okay, so what did you do? You highlighted the plot.
Oh. Yeah, I highlighted the corresponding code. So the x argument is what's on the x-axis. The y argument is what's on the y-axis.
Yeah.
And then using all the defaults, after I transfer the code to R, this is what I got. Okay, so there's a simple scatter plot. We can make this look a lot better, not go with the defaults. So, and often this is what you want to do because you don't want to just leave off labels or do other or make the plot. You often want to make the plot look prettier. And so what I've done, just for illustration purposes, is show a whole bunch of optional arguments in the next plot function. Starting on page 44, I go through all the options. So let's take some time to do this. A lot of these are intuitive, these argument names. So xlab means, what's the x-axis label? Ylab, y-axis label. The main argument, what's the title of my plot? The xlim argument, x-axis limits. I'm going to go from 0 to 4.5. Notice how I'm using that C function to combine the bottom number and the top number. Ylim, in a very similar manner. Color. COL is the argument name. And you can pretty much put in quotes whatever color that's common. You can put it there. If you want to see a listing of all possible colors, hold on. If you want to see a listing of all possible colors, there's a function called colors. And you can see there are 657 of them.
So if you just do red, blue, would that be on this list? And
I don't, you mean, is there a particular name called red, blue?
no, I mean
Or-
red is one.
Yeah, red is one, blue is another.
Red 1, red 2, red 3, red 4.
Yeah, there is just plain red.
There's a plain red.
Yeah. Yep, just different shades. And if you're really, really interested in what all those different colors are, there's a link. Someone, I guess, had some free time, and they decided to make a little chart that has all the colors corresponding to the location of the number, basically. You could also use numbers, too. So color 1 is white. I could actually put quote, white, end quote, or I could say COL equal 1 if I wanted to instead.
And so if you used it enough, you know the numbers, you can just plot the ones that you want.
Yeah, you could. I mean,
Obviously, this list was added to over time and not put together. About 650 at the same time.
yeah, perhaps. So those are all the colors. Let's talk about plotting characters. This is located on page 44. So there's an argument by the name of PCH for plotting character. And in this particular case, you have to actually use the number. And so those are, by default, the 25 that are available. I believe you can make more if you want to. I have not had to in the past. So notice what 1 is. 1 is the open dot. And that's the default for the plot function. And so that's why we have an open dot there. And it's good to use an open dot because, if you had two data values that are very similar to one another, you want to try to prevent overlapping. Or you don't want to have them completely overlap and then perhaps miss something, like if you had a solid dot. So that's why open dot's the default. So there's also a CEX argument. This is not necessarily obvious, but this corresponds to the magnification level of the plotting characters. In other words, how big do you want the dots to be, for example? So they go from like a default value of 1, and if you do 2.0 instead, it's twice as big. 0.5 would be half as big. There's an LWD argument, line width. How thick do you want if you're plotting lines, or if you're plotting, in this case, our circles, how thick do you want that to be? And the default is 1.0, and again, you can use 2 for twice as big. Also, I have an argument listed here called panel.first. This allows you to do a variety of things of what you want to maybe do in your plot window before you do the actual plotting. And the only one that I've really found useful is the grid option to allow for grid lines. So I say grid lines, COL equal gray, so gray grid lines. LTY stands for line type. I'm going to use a dotted line. In the notes, you can see a listing of the various, by default, line types. You can use the numbers, or you can use the names in quotes. There's ways that you can get a lot more than just 6 line types as well. Off the top of my head, I don't remember what they were, but I did use it just recently because I had to do that. But you can actually have physical control of how far you want dashes to be, or how long you want the dashes to be. A lot of these argument values are actually not shown in the help for plot. Sorry about that. So they're not in the help for plot. Rather, they're in the help for a function called par. Par stands for graphics parameters. So there's a whole bunch of other arguments that we could use, and they're all listed in this par function. And we'll look at some examples of using the par function for other purposes as we go along. So let's, why don't you actually create the plot? So just highlight, run the code, and this is what your plot should look like. It looks a little bit nicer. Or at least I think it does. Well, how do you get this plot then into a word processing document? Okay. Make sure that you are actually in this window with your mouse, or it's active, I should say. Click on File, Copy to the Clipboard as meta file. Let me just simply open up a new document here. Oops. And paste. You can also, if you really wanted to, save out the file, save as, and you have a variety of different options as well. There's actual code that you can use to automatically save out the file if you really wanted to. So there you go. That's basic plot. So that takes us to page 45. One of the most common questions that I get from students when I first teach them about R is that, well, how can I have maybe greater control over the tick marks in my, for my x-axis and my y-axis? Well, what you can do in R, and you don't need to run this, I'm just going to go through it fast, is that suppose I want to have complete control over how my x-axis tick marks are given. I can say in plot x, AXT, axis, tick marks, that's what that stands for, equal n, or equal quote, end quote. What that means is don't draw anything on my y-axis. So let me just try that, I guess real quick. And notice you don't see anything on the x-axis. To then put something on the x-axis, there is a function called axis. And without going into all the details of the arguments, basically side equal 1 means you want the x-axis. And then I want to draw marks at, what do you think this does? The SEQ function.
The range 0 to 4.5 and the difference is 2.5.
Yeah. So SEQ stands for the sequence function. I could actually run the sequence function outside of R. I'm sorry, outside of the axis function. And if I just do this real quick. There's my major tick marks, you could say. There's code also in the notes to show you how to get the minor tick marks as well. Maybe little lines between 0 and 0.5, for example, if you want to be really precise in how you're looking at the plot. Okay, are there any questions?
That didn't change the grid.
No, it did not. And that's because actually I drew the grid there first. Now, obviously, if you specify some other kind of axis limits there, or tick marks placement, that could screw up with where the grid lines are. And there's ways that you can specify exactly where the grid lines are. Okay, let's see. We're on page 47 then. So now I have a plot. It looks like I have a pretty decent linear relationship between my x variable, my y variable. Why don't we fit a regression model? So let's do that. The function to do that in R, LM. L stands for linear, M stands for model, linear model. Here's the syntax. Formula equal, that's where you specify your model. Put your dependent variable, your response variable first, and then separate that from your independent variables by using a tilde. Other languages, for example, for SAS, if you're using proc reg, there's a model statement where you would say like y equal x. Well, we can't use equal because we already are using equal to mean something else inside this function. So R says let's use a tilde. Put your independent variable or your explanatory variable then on the right-hand side of the tilde. If I had more than one variable, I could use a plus sign to separate them. It doesn't mean add them together. It just means I want this variable and this other variable. Then I specify my data in GPA. That's the data set.
I'm going to use the full,
All data.
both variables.
Yeah, so my data set, or both variables exist in GPA. Yes, thank you. If I wanted to, I could have also did this. I could have did this and got exactly the same result, where I'm not specifying a data set, but I'm specifying exactly where it is in the data set. So you might notice, for example, in the plot function, notice that's the way that we basically had to specify the variables. There's not like a data argument. Where in the LM function, well, there is a data argument. It's a quirk. It's unfortunately, the syntax is not exactly the same between different functions. So then I'm going to make this assignment into an object called mod.fit, for the lack of a better name. So like model fit. And everything then goes into mod.fit. Why don't you go ahead and do that? Because I want to show you some stuff about what's inside of mod.fit. So often, in other software packages, I haven't used SPSS for a long time, so I can't comment on that, but at least for SAS, when you say SAS, give me the regression model, it spits out a whole bunch of information in the output window. Okay? Notice what R did. Nothing. And so, if you're just a new user, you might think, did it work? Well, how about we type the object? And we get a little bit of information about what's actually in there. So my y-intercept for my model is 0.7076. The slope is 0.6997. Okay. There's actually a whole bunch more information in there. The way to see that is to use a function that we looked at before. Names. Names mod.fit. Hit enter, and now you see a listing of everything that's in there.
Why doesn't it just show it to what's going to be in?
Well, the difference between what R and maybe another software package is that instead of giving you a whole bunch of stuff or a lot of stuff you don't want, what R says, I'm not going to give you anything. You have to actually ask. Tell me exactly what you want. You can think of it, I know back, I guess, a number of years ago where we print off pages and pages and pages of SAS output, where in R, you're not like killing trees because the only stuff that you're going to get is the stuff that you're going to ask for.
So if
also
you
nice-
do want, sorry.
Go ahead.
If you do want all, is there something like give me all?
Not exactly, but what we can do is this. It's getting a little ahead of ourselves, but we can do this.
It looks like it's, because it's in that names function, it looks like it's much easier to access individual output
Exactly.
coefficients than being buried in each tables.
Exactly, and sorry to be given another SAS reference, but that was one of the problems that people had with SAS is that I see this in my output. I just printed it off. How do I get it? How do I get it into maybe a data set? That was a big problem for a number of years, and then they had something called the output management. I thought there was a different the ODS system, and now you're able to tell SAS, I want this table that appears in the output. I wonder if they got the idea from looking at what S Plus and R was doing, but that's kind of what's happening here. Is that instead of printing off everything, though, you now have access to it this way. Now, if you wanted to, let's say, to print all, well, what might be better to do is just simply print a summary. And this is the usual output that you would often see first, when you do some other kind of software. So you see the usual tables. So do we have evidence of a significant linear relationship between high school GPA and college GPA? Does it look like it, based upon what you see there? Yeah? So the p-value is located in the PR greater than absolute value of t column. So we have a very small p-value. Have information about residuals. Let's look at the R squared, 0.8354, and that's nice. So we got a lot of useful information in this summary. Now remember, though, we used summary we used summary before with the data.frame, and we got a totally different result. Stay tuned. We'll talk about why that happens. Yeah.
So if I want to save this, I have to copy paste.
What exactly do you want to save? Do you want to save this?
Result to Excel file because I'm running 100 models and I want to have all those results somewhere to look there.
Okay. Yeah, I'm sorry. You want to look at what kind of file?
I want to run 100 models.
Yep.
And I want to have all the output or somehow make a table in my Excel file so I can look what my R squared is.
Perhaps, for example, you might want to, let's say, keep the R squared, or keep. How about we just do like the y-intercept, and the slope.
Yeah.
Okay.
Yeah.
Suppose I want to summarize that for all 100 models. Well, notice here for the names mod.fit here, it lists what's actually in there. So if I say mod.fit $coefficients, I can access it. So what you could do is fit your 100 models,
And it has a different name for
and
each
then,
model.
yeah, different name for each model. Or, like if you're like familiar with like a looping structure, you could write a loop and put everything in there and put it in like a data.frame, and there you go.
So the mod.fit will need to change for every model, so mod.fit 1, 2, 3,
Because that's the name.
Well, it depends upon what you exactly want to do. For example, let me get Windows Journal out. Hold on, so I can write on it. So what you could do, for example, let's say you want to fit. This is Windows Journal. It comes with. This is a tablet PC. It's come with tablet PCs since they've existed. So anyway, what you could do is, let's say you want to fit 100 different models. So you could say something like this, and I will use our code. And I know this is it's going to be kind of complex right now, but a little bit later on in the notes, it will make more sense. And now you can just think of it as this is like pseudocode, and it gives you the structure of how you would do something like this. So I could say for I in 1 to 100, let's say, and bracket, let's say I'm going to use the LM function every single time, where somehow I'm going to maybe change my data set somehow, put the results into mod.fit, and then maybe I have a save matrix called save.mat, gets, let's see, mod.fit $coefficients. I'm going to have to actually put some indices here. Of course, I can obviously just erase. So save, we'll just call it save, bracket, I, comma, and bracket. So the ith row is going to get everything that's from mod.fit $coefficients, and just end it. You end it just like what we do with functions, use those little curvy brackets. You would also need to, at the very beginning, initialize this matrix. And I'll initialize it with NAs. You can actually use the word or use the letter NA. Number row equal 100. Number of columns equal 2. If we're just simply doing simple linear regression models. And that's how you would do it. That would be one way, I should say. There actually could be more efficient ways than using actual looping structures. There's something, excuse me?
I was just thinking, if you had a matrix of models for each vector.
Well, if we get to it, this is in section 6. I show you a for loop, and then I show you a more efficient structure to do exactly the same thing that a for loop would do. There's something called an apply function. And you can say, let's say I want to apply maybe the LM function to every column of my data set. And it will spit everything out for you. It's very slick. Let's see. Okay, so let me actually keep on going in Windows Journal here. So this mod.fit, the way that you can access components to it is very similar to what we did with the data.frame. Mod.fit $coefficients. There's also something called residuals. Mod.fit $residuals. So basically what we have here, we have this kind of a structure. Here's mod.fit, and we have coefficients. We have residuals. And you can look at all the different names that we have. For example, fitted.values, which basically contain like the y-hats. And we have a whole bunch of things linked to it. This kind of object in R has a special name. It's called a list. It's a very easy way to combine things that might be of, let's say, different lengths or different types. Combine it all into one component so that you can access it later. And again, the way that you would access it is through using that $sign syntax and then whatever you want to access. So, for example, mod.fit $ call. Here's my actual function code. Mod.fit $, let's do residuals. There's all my residuals. So that's how I can access all that stuff. Now, what we saw before with a data.frame, that GPA data set was a data.frame, that's actually a special kind of list. It makes it's special because every component in that list has exactly the same length. We had 20 high school GPAs, we had 20 college GPAs. So it's a special kind of list. But in a list structure, you don't in a list itself, you're not constrained by that at all.
How does it know the difference? We didn't define anything, so it's because of the function used. Function used, that's why.
I'm sorry, say it again, please. Well, how does it know to create a list?
How does it know there's a difference, that this is a different kind of list as that? I think it's because of we've used the LM function.
Well, yeah, so we use the LM function to estimate the model. And later on, we'll actually look at the code for the LM function. Since this is open source, nothing's hidden. You can actually see how the actual model's being fit. Inside that function, there's going to be a place where, in the code, where it says, I want the result that's returned to be a list. Okay, and have these components. So if you wanted, some more information about, well, what is all that stuff that's in there? Well, look up help LM. And again, you have a description. You have the full syntax. So notice how we have formula there. We have data there. We were talking about something earlier about subsets. There's a subset argument. And you see information about the arguments. Let me just keep on paging down. What I want to get at, and this is on page 48, we have something that's titled value. That means what's returned to the user. And there's a listing of everything. Okay. Any questions?
Does this have any manuals where the interpretation of the results are also explained? So say I'm running something new that I haven't run before, and I'm having trouble reading the output. So I guess PSS or whatever other programs can actually help you interpret that.
You can buy a book. I don't know specifically for this example, but there are a number of online, or there are a number of help manuals. So we saw that our introduction, it's a PDF file. You might want to look there first to see if that's explained. I wouldn't be surprised if it is, since it is a basic thing. In other cases, let's say if maybe you're doing something that's a little bit more complex. Maybe it's a user-contributed package. The person who wrote the package on the CRAN might have put what's called a vignette, which is basically, I think exactly what you're looking for is, it gives maybe some examples, a step-by-step description of what to do, and interpretations. So yeah, those exist. And otherwise, one of the biggest things right now in statistics books, if you haven't noticed it, almost every new stat book out there, maybe not all, has R in its title. Okay, because they're using R. Well, then they're going to show you, hopefully, how to interpret the package or the function that they're using. And in fact, I think I mentioned that I'm writing my own book. It's called Categorical Data Analysis with R. I felt bad about putting that on there because I'm like jumping on the bandwagon, Oh, let's have another R book, but there's no books out there that's just on categorical data analysis. And so, anyway, page 49 then. Often what you like to be able to do once you fit the regression model is that you like to look at your data and look at it side by side with, let's say, the predicted values and the residuals. So how could we do that here? Well, we know where the residuals are. We know where the predicted values are. It's at fitted.values that I briefly mentioned before. Let's combine all this stuff together in a data.frame. So let's try that. So data.frame, this is the first time we've seen this function. I put my data set, and then, and perhaps I got a little bit too fancy here, I want my I want my mod.fit $fit, can't talk now, mod.fit $fitted values. If I just execute that small segment of code, you see indeed those are my y hats, let's say. And if I want to round to 2 decimal places, I can use the round function with a comma 2. So it's nice. And then to actually put this in my data.frame, I actually create a new variable called college.gpa.hat. I do a very similar thing with residuals as well. And basically what we're doing here is that we're combining by columns of data. So you're going to have GPA here, the GPA data set that is, then you'll have all the y hats, and then you'll have all the residuals right next to it. If you want, you can execute that code to see what actually it looks like. I'm going to use a head function to look at just the first few values, and there's a nice little data set. So the predicted value for the first individual was 2.83, residual 0.27, which is 3.1 minus 2.83.
So how do you see that in Excel, that data that you just, now you have this, it's showing you the first 6 values?
Yeah.
You have to go back to that earlier command that we learned.
So you could just see the whole thing by typing save.fit if that's what you're talking about.
But if I want to see it in Excel?
If you want to see it in Excel, what you could do is export it. So,
The one we did before?
yeah. Yeah, or cut and paste, yeah. Okay. So page 50 then. Towards the bottom. Well, what happens though if you had a categorical independent variable? How does R work with that? What I decided to do was just create a variable myself, and you don't necessarily, I'm not going to go through the details about how I created it, but what I did was I created a variable called where.live. Where does the student live? So I put this in a data frame called GPA.2. Maybe they lived with their parents through college. Maybe they lived in the dorms. Maybe they lived off campus. So obviously, it's a categorical variable. How can we include that in our model, and how does R treat it? So if you want to, you can execute. You can execute this segment of code that I'm highlighting here. It's up to you if you want to do this. Where basically I create the data set. And don't worry about the levels function, contrast function right now. And then go all the way down to the LM function. And notice how I have a second variable called where.live in the formula argument. So if I run that and do a summary, here we go. Oops, sorry, summary mod.fit2. So what did R do?
So this is your second model, right?
Yeah.
So that's reason 2.
Yeah. So what did R do here? It basically created 2 indicator variables to represent a categorical variable with 3 levels. And it decided to use live off campus as one, or I guess off campus is one indicator variable, and with parents another indicator variable. Meaning with parents, that variable would be a 1 if the individual lives with their parents, a 0 otherwise. Okay.
So how do you decide?
Good. Yeah, that's what I was getting at. So if I say levels, let's see. Actually, levels GPA2 $where.live. It tells me the levels of this categorical variable. And notice by default it puts them in alphabetical order. Also by default, it does what is often referred to as set first level equal to 0. In other words, the base level for where we're making the comparisons to is the dorm level. So you don't see a dorm indicator variable there. Okay. Also, you can go further and see the coding structure by using the function contrast with that where.live. And there you see actually how the indicator variables are formed.
What? Sorry.
That's
Why
fine.
if that variable, you had it like a string, dorm off campus. If I had it 1, 2, 3, you would know that it's a categorical.
Thank you for the lead-in, because what I was going to discuss on page 52. I guess I was thinking right when I was preparing this. So if you have, let's say, a numerically coded categorical variable, what you need to do is inside the formula argument, use the word or use the function factor. Basically, categorical-based variables in R are actually a specific kind of object called a factor. Okay? And actually, there's ways with that factor that you can actually change the ordering of the variable, ordering of the levels. So, for example, if you wanted to do something different from what R did by default.
Is there a limit to how many categories you could have? So 7, 10?
I think you're only limited by the actual number of observations, because obviously you can have, I guess, more than the number of observations. Well, what happens though if I want maybe a squared term in our model? Maybe high school GPA squared. Well, what you need to do, and this is a little bit weird syntax, use the I function around it. So you would think you just say caret sign 2. Instead, you have to actually enclose that or put the I function around it. I like to think of it as interpret. Interpret this as high school GPA squared. Now, you might be wondering, why is that? Well, the reason being is because suppose instead you had this formula here. If you said x1 plus x2, that whole quantity caret sign 2, what R interprets that as basically you want basically the main effects and then the interaction as well. So that's why. So if I had maybe 3 variables there and I had a caret sign 3, main effects, pairwise combinations, and then the 3-way interactions. Okay. So why don't we go back before we break for lunch? Why don't we take a look at this extra document again? So let's talk about these packages. Again, a package is just basically a group of functions that someone's put together. And there are over 3,000 packages available on CRAN, Comprehensive R Archive Network. And we've kind of actually went through this a little bit already about how to find a package to satisfy your needs. You can go to the web page, maybe do a quick search, maybe search the listserv archive. There's a variety of ways to do it. There's not necessarily one best way, though. And also, we just kind of mentioned this too. And I will actually go here. I don't need to go there. So when you go to a particular web page for a package, and maybe it might actually be best for me to do that. Okay, so I'm going to look at the web page for RODBC. So I'm going to find RODBC. And there's a lot of R's, as you would expect for a software package called R.
Why is it called R?
That's a good question. There's actually a few reasons. First, there already was something called S. Okay, and so let's pick R. The second reason is the 2 guys who developed it. The first names are Ross and Robert. Okay, so here's the web page then for RODBC. In fact, there's ways you could download those. You see like a Windows binary file there. That's basically what R is doing when you download the package from R itself. It's grabbing that, pulling it in. unzipping it and installing it. But what we see here, too, is the reference manual. rodbc.pdf, well, that's basically all the help files that correspond to that package that would already be installed on your computer, but it's just now in a PDF. Then we have this thing called a vignette, and that gives you kind of, gives you some examples of how to actually use the actual package. Remember, too, that with every function, typically there's examples, too. Just not necessarily there's no explanation of what the function, what the examples do. And so that's the help for a package. And typically all packages are structured in this, or the files for all, web files for every package is structured in that way. Okay. So this is also kind of something that we touched on. Can you trust R? It's open source. Anybody can make changes to it, kind of. Again, there's this R core group of about 20 people that really control, the base implementations of R. So when someone's saying, can you trust R, basically you're saying, can someone trust the functions that are inside of packages of R? So here's my general, let's say, rule of thumb then for my levels of trust for packages. Packages that are available in the default installation of R, yeah. I mean, our first implementation, beta testing, was in 1996. So 15 years we've had to get the bugs out and stuff. And yeah, there are bugs in it, but you often see if you follow the listserv, they're solved. And I, at least in the past, don't see any more bugs with the main R software. Packages written by leaders in the area of interest. Well, most likely, yeah. They should be knowing what they do. Packages written by people you trust. Well, hopefully, yes. Or most likely, yes. I'll use that terminology. Packages that have been peer-reviewed by the R Journal, Journal of Statistical Software. Yes, most likely. Now, we come to the next level. Packages from unknown authors, hopefully. Packages with version numbers beginning with 0. That's typically meant for beta testing, for example. Well, hopefully. Packages created for a student's dissertation, hopefully. Look at the revisor. See if you can trust the revisor, maybe. And packages just recently created. Well, really hasn't, been tested a whole lot, maybe, by others. So maybe, hopefully. So, I don't mean to scare you about using R. You just have to use R in the best way possible. And that is stuff that's in the main core of R. Yeah, it's probably going to work. If you know the person who's doing it, it's probably going to be okay to use. If you have no idea who this person is who wrote this particular package or why they wrote it, you just got to be careful. Note that these R packages, they're submitted to R, and they will stay there for a period of time. And if let's say somebody wrote their dissertation and then they don't touch it anymore in a couple years, the package will be removed. Because then, you might be concerned about, well, are they updating it corresponding to new versions of R? And so, that's one mechanism that's used to get rid of stuff that maybe you might be a little bit scared about. And lastly then, if there's any doubt about a package, remember, you can see the actual code. And we'll see an example of that coming up. You can see all the code. Nothing's hidden. So, with that, I think it's a good time for us to stop. Now, in the original schedule here, I have us getting back here at 1:15. I would be happy to start earlier if you would like. It's up to you. What do you think? Earlier? How early? You decide.
Is lunch outside, or are we going and buying it?
Lunch is tickets.
Tickets, okay. So we could see where we could buy it,
Buy
bring
it,
it back
come back.
in here.
I've got a client lunch that I need to go to for a few minutes. But
So,
30 minutes, or?
yeah, 30.
30 minutes? Okay, well, we'll hopefully start back up at 12:30. If we're not all here, we'll just wait a little bit, okay? Okay.